Hello, today I'm gonna say about the database encryption. This is Sai. In this we covered what is database encryption, database security properties, where should be encryption performed, types of encryption, performance, securing data in motion. What is database encryption? First of all, we have to know encryption. Encryption is nothing but conversion of the data into a form so that it cannot be easily understood by the unauthorized people, like a plain text with the conversation with like applying the encryption. we will be uh, we will be converted into plain text into ciphertext by the applying the encryption algorithms. And database encryption refers to the use of encryption techniques to transform a plain text database into encrypted database, such that while encrypting by encrypting the database, the unauthorized people cannot be seen the data, so that it's make the unreadable data, and we can be decrypted the encrypted data with the encryption keys only. Database security encompasses mainly three properties. One, it is confidentiality property, integrity property, availability property. uh, Roughly speaking, the confidentiality property enforces predefined restrictions while accessing the protected data, thus preventing disclosure to unauthorized persons. The integrity property guarantees that the data cannot be corrupted in a invisible way. Finally, coming to the availability property, it ensures timely and reliable access to the database. To, to preserve the data confidentiality, enforcing access control policies defined on the database management systems is prevailing method. An access control policy that is set to set of authorizations can take different forms depending upon the underlying data model, example relational XML, and the way by which authorizations are administered, following either a discretionary access control DAC or RBAC, which stands for role based access control, or mandatory access control MAC. Whatever the access control model, the authorization enforced by the database server can be bypassed in a number of ways. For example, like an intruder can inflate the information system and try to change the database footprint on disk. Another source of threats comes from the fact that many databases are today outsourced to database services providers DSP. Finally, a database administration DBA has enough privileges to tamper the access control definition and to spy on the DBMS behavior. With this spirit of an old and important principle called defense in the depth, that is layering defense such that attackers must be get through layer after layer of defense, the research of the cryptographic techniques to complement and reinforced by the access control. The purpose of the database encryption is to ensure the database capacity by keeping the information hidden to any unauthorized persons, like say it introduce. Even if the attackers get through the firewall and bypass access control policies, they still need the encryption keys to decrypt. Encryption can provide strong security for data at rest, but developing a database encryption strategy must take many factors into consideration. Like example, where should be perform the encryption in the storage like where should the perform the encryption in the storage layer or in the database or in the application where the data has been produced, how much data should be encrypted to provide advocate security, what should be the encryption algorithm and mode of operation, who should have access to the encryption keys, how to minimize the impact of database encryption on performance. For next, coming to the encryption level, like first one is a storage level encryption. In the storage level encryption amounts to encrypt the data in storage subsystems and thus protect the data addressed from the storage media theft. It is well suited for encrypting files or entire directories in an operating system's context. From a database perspective, storage level encryption has the advantage to be transparent, thus avoiding any changes to the existing applications. On the other side, since the storage subsystems has no knowledge of database objects and structures, the encryption strategy cannot be related with user privileges, like example using distinct encryption keys or distinct users, or not to data sensitivity, thus selective encryption, that is encrypting only portions of the database in order to decrease the encryption overhead, that is limited to the file granularity. And moreover, selectively encrypting files is risky, since one should ensure that no replica of sensitive data remains encrypted, like examples in log files, temporary files, or etc. Then the next one is database level encryption. In the database level encryption allows securing the data as it is inserted to or retrieved from the database. The encryption strategy can thus be the part of the database design and can be related with the data sensitivity and or user privileges. Selective comparison is possible and can be done at various granularities, such as tables, columns, rows, where it can be related with some logical conditions like salaries, etc. Depending the level of integration of the encryption features and the DBMS, the encryption process may incur some changes to application. Moreover, like it may cause DBMS performance degradation, since encryption generally forbids the use of index on encrypted data, indeed unless using specific encryption algorithms or mode of operation, uh, like example order preserving encryption, ECB mode of operation preserving indexing encrypted data is useless. For both strategies, data is encrypted on the database server at runtime, thus the encryption keys must be transmitted or kept with the encrypted data on the server side, thereby providing a limited protection against the server administration or any intruder. That may be the unsurprisingly the administration identity. Indeed, attackers could spy the memory and discover encryption keys or plain text data. Like it said, like the integration of the encryption features and the DBMS, and moreover it may cause a DBMS performance degradation and use of the index on encrypted data. The third one is application level encryption. And in the application level encryption, it moves the encryption or decryption process to the applications that generate the data. Encryption is thus performed within the application that introduce the data into the systems. The data is sent to the encrypted, thus naturally stored and retrieved encrypted to be finally decrypted with the application. This approach has benefit to separate encryption keys from the encrypted data stored in the database, since the keys never have to leave the application side. However, the application need to be modified to adopt this solution. In addition, depending on the encryption and granularity, the application may have to retrieve a larger set of data that one granted to the actual users, thus opening a security breach. And indeed, the user or any attacker gaining access to the machine where the application runs may hack the application to access unauthorized data. Finally, such a strategy induces performance overheads like indexes on encrypted data are useless and forbids the use of some advanced database functionalities on the encrypted data like stored procedures, uh, like example code stored in DBMS which can be shared and invoked by the several applications, and triggers, that is code fired when some data in the database are modified. In terms of granularity and key management, application level encryption offers the highest flexibility since the encryption granularity and the encryption keys can be chosen depending upon the application logic. Uh, the three strategies described above are pictured in the this one. We can see the first one, the storage level encryption. The second one is a database level encryption, and the third one is applicable application layer encryption. And for the second one is the types of encryption: symmetric and asymmetric encryption. uh, for coming to symmetric encryption uses one shared secret, like one encryption key that is shared between two parties, and its most simple type code we can code up ourselves. Only one key is needed, safe method needed for the transmission of the key. General symmetric key encryption used for field level security in database systems because it is much more efficient. And coming to the asymmetric asymmetric encryption may be used to fetch a symmetric key but is almost never used for data encryption tasks. um, Public key is posted to the public encrypt and decryption done only by the private key. Web browser and web server HTTPS, for the examples, and the VPN client and server FTP. um, for generally independently on the encryption strategies, the security of the encrypted data depends upon the encryption, which depends upon the encryption algorithm, and encryption algorithms and the encryption key size and its protection, even having adopted some algorithms such as AES, and the ciphertext could still discloses plain text. And for example, if encryption algorithm is implemented in electronic codebook mode, ECB, identical plain text blocks are encrypted into identical ciphertext books, thus disclosing repetitive patterns. Like we see symmetric encryption for symmetric encryption for the data, we can see here uh, we are encrypting the visa code. After applying the encryption code, the encrypted data will be like this and will be done with the encryption algorithms or key. And then next, it's a decryption. We can see the general example, like it's a already encrypted data, we are giving a decryption algorithm like our key, so that again it converts to the normal data. Like I said before, it's just an example, like a plain text encryption ciphertext, and ciphertext decrypt with a key or algorithm, and it comes to the normal plain text. uh, and various symmetric algorithms refers to the RC4, DES, 3DES, AES, transportation, substitution, folding, shifting, encryption algorithm, like it's called TSFS, transparent data encryption, TDE. And we can see that this is the like a diagram of the DES encryption of 64-bit plain text, 56-bit key, and after all the operation is done, it's converted into ciphertext. AES encryption has no, we seen like AES encryption always involves some data which is to be encrypted, and encryption key and possibly an initialization vector. The 5 NIST approved modes of encryption which provide different ways of using these elements. The modes of encryption are ECB, CBC, CTR, OAP, CFB. You can see that like a uh, ECB electronic codebook, CBC cipher blocking chaining, CTR counter, OAP output feedback, CFB cipher feedback. Encryption keys. While coming to the encryption keys, um, we can say the most commonly used key sizes are 128, 192, 256 bit, like 16 bytes, 24 bytes, 32 bytes. The larger the key, the more secure the encrypted key information, and the more processing is used during the encryption. And TSFS is a symmetric database encryption algorithm that uses three keys with an expansion technique to provide high security for various modules like transposition, substitution, folding, shifting. And the performance encryption will be impact CPU utilization, total job run times, interactive response time, and be sure to profile your application and create proof of concept test. Ask your software vendor to perform for performance information. And the next we come through the complaints logging, like log access to sensitive data, or log user access and authentication denials, or log application access denials, log database field level access denials, log access to configuration like key management, user control, system option. System logs should be secure from modification or deletion. And securing data in motion, like transfer data that is already encrypted, use secure protocols like HTTPS, SSL, FTP, and SFTP. Use secure VPN networks. Use file encryption technologies such as pretty good privacy PGP. And for the complete conclusion, like maybe we can conclusion, we have to know what like where the applications to be done, like from the several years, like we've seen most DBMS manufacturers provide native encryption capabilities that enable applications like developers to include additional measures of database data security. And for the SQL Server 2008 introduced like a transparent data encryption TDE, as we seen, which is actually very similar to storage level encryption. The whole database is protected, and database encryption is increasingly an important and more often required security control, and it's also effective layer of defense if properly implemented, because the intruders cannot be know the important matters. Protecting keys hard to do and is most common weakness. And the database level encryption with security server approach mentioned above, proposed by like IBM DB2, the database encryption experts, and can the vendors and third party like Progressivity, RSA, BSAFE, and products can adapt to the most DBMS engines, and it's all the key management and the encryption requirements needs to be defined early in application requirements, like while all existing commercial database products adopt classical encryption algorithms for the database encryption. um, Specific encryption schemes have attracted much attention in the academic field. In this like paradigm, database service providers offer its customers seamless mechanism to create, store and access their database at the host site. In this context, the database server may manage encrypted data and having access to the encryption keys, and by use these guidelines during the architecture design and implementation of the encryption, like a privacy harmonic pH encryption is a form of like a encryption where one can perform some specific algebraic operations on the plain text, performing it possibly. uh, an alternate purpose is to like use classical encryption algorithms and to store additional auxiliary fuzzy information next to ciphertext in order to follow partial query processing on encrypted data. Such auxiliary information shouldn't reveal plain text context. Thus, a trade-off exists between security and efficiency. And for the new database encryption strategies, currently existing architectures including database encryption are not fully satisfactory, since as mentioned above, encryption keeps appears in a plain text in RAM of the server or with the client machine where the application runs. HSM acts as a safe storage to minimize the risk, diminishing the keys exposure during this lifetime. And for the two architecture can be considered server HSM when the HSM is shared by all users and is located on the server, client HSM when the HSM is dedicated to a single user and is located near the user, potentially on the client machine. And by this I and end up this topic. Thank you.